Long before it became a staple in kitchens around the world, baking soda had a fascinating journey from the earth itself to the shelves of grocery stores. Baking soda, chemically known as sodium bicarbonate, is a white crystalline powder that has been used for centuries in various forms. Its story begins deep within the earth, where natural mineral deposits hold the key to producing this incredibly versatile compound. The primary natural source of sodium bicarbonate is a mineral called trona, which is found in massive underground deposits, most notably in the Green River Basin in the state of Wyoming in the United States. These deposits were formed millions of years ago when ancient lakes evaporated and left behind concentrated layers of mineral-rich sediment. Mining companies extract trona ore from depths that can reach hundreds of meters underground using a process called room and pillar mining, where large sections of ore are removed while leaving supporting columns behind to prevent the tunnels from collapsing. Once the trona ore is brought to the surface, it undergoes a series of carefully controlled chemical and physical transformations to become the pure baking soda we recognize. The raw ore is first crushed into smaller pieces and then dissolved in water to create a solution. This solution is filtered to remove impurities such as dirt, rock fragments, and other unwanted minerals. The filtered liquid is then heated in large industrial furnaces, causing a chemical reaction that converts the trona into sodium carbonate, which is also known as soda ash. This heating process, called calcination, drives off carbon dioxide and water vapor, leaving behind a more concentrated and refined compound. The soda ash is then dissolved again in water and treated with carbon dioxide gas under carefully controlled pressure and temperature conditions. This critical step triggers a chemical reaction where the carbon dioxide combines with the sodium carbonate and water to produce sodium bicarbonate crystals. The chemical equation behind this transformation is elegant in its simplicity, yet the industrial process requires precise engineering to ensure consistency and purity in the final product. After the sodium bicarbonate crystals begin to form in the solution, they are separated from the liquid through a process called centrifugation, where the mixture is spun at high speeds to force the heavier crystals outward and away from the remaining liquid. The collected crystals are still slightly wet at this stage and carry trace amounts of impurities from the production process. To address this, the crystals are passed through large industrial dryers where carefully controlled streams of warm air remove excess moisture without causing the sodium bicarbonate to break down. Temperature control during this drying phase is absolutely critical because sodium bicarbonate begins to decompose into sodium carbonate, water, and carbon dioxide when exposed to temperatures above approximately 50 degrees Celsius for extended periods. Once dried, the crystals are milled, meaning they are ground down to a specific and uniform particle size that determines how the final product will behave in cooking and other applications. Finer particles dissolve more quickly and react faster, which is why different grades of baking soda exist for different industrial and culinary purposes. Before baking soda reaches consumers, it passes through rigorous quality control testing at multiple stages of production. Laboratory technicians analyze samples for purity levels, particle size distribution, moisture content, and the presence of any contaminants. Food-grade baking soda must meet strict standards set by regulatory bodies to ensure it is safe for human consumption. The testing process involves sophisticated equipment that can detect impurities at incredibly small concentrations, ensuring that every batch meets the required specifications. Once approved, the baking soda is transported to packaging facilities where it is measured and sealed into the familiar boxes, bags, and containers that line store shelves. The packaging itself is designed to protect the product from moisture and carbon dioxide in the surrounding air, both of which can cause premature chemical reactions that reduce the effectiveness of the baking soda over time. From ancient mineral deposits buried deep underground to the small orange box sitting in a kitchen cabinet, The journey of baking soda is a remarkable example of how natural chemistry and modern industrial processes work together to create something beautifully simple yet endlessly useful.